Factor first. Factor, factor, factor. You cannot simplify unless you have common factors. So on the top, is there a common factor that I can remove from these two terms? No, they have nothing in common. So my suggestion is still enclose them in parentheses. Remind yourself that it is that is now the factor. It is itself. It is prime, if you think about it. On the bottom, it's a quadratic trinomial. We can attempt to factor it like this. Right? X is in front. Now when we were doing this, last week it was with the box method, trying to find numbers that multiply to be negative 48 and add to be negative 2. Those two numbers are positive 6 and negative 8. So these binomials are the factors of the denominator. I have factored this. Do I have a common factor on the top and the bottom?
Yes.
Now I do. X plus 6. I can cancel them. And again, the key to this problem is these parentheses. That tells me that this is being multiplied by this. You want to know what screws people up really bad? I'm throwing all these like pitfalls out there to be like, gotcha. Don't write this down. Don't write this down. It'll happen. It'll happen to you at some point. And you'll be like, oh, parentheses, parentheses, I'm going to cancel them. This is not being multiplied by this. This is being added to that. So even though the parentheses are there, it's not being multiplied by something. It's being added to something. And the fact that that addition is there, addition is a very restrictive operation. It's very strict rules, okay? Multiplication is kind of just like in college, like does whatever it wants, all right? You can't cancel these, even though but there's parentheses. Yes, but these parentheses are not indicating multiplication, so that you cannot cancel in that case. All right, let's do another one. On the top, any common factors in the numerator here? No. How do I know? Well, this has a y, this doesn't, so I can't take y out. This is prime. 7 is a prime number, so its only factors are 1 and 7. And 7 is not a factor of 8, so I can't take out a greatest common factor. So, what do? Put parentheses around. On the bottom, what do you see? What operation do you see? Subtraction. Subtraction of what? These two things. And these two things are squares. So we have the difference of squares. 64 and 49 are both perfect squares. And I have y squared here. So I can factor this difference of squares into conjugates. The conjugates would be, the square root of 49 is 7. The square root of 64y is 8y. One with a minus, one with a plus. So those are the conjugates I get from the difference of squares. Now when you look at this, do they have any common factors? Is there anything that's exactly the same? First glance, you would say no. But you want to say, oh, right? You're sitting there. Hopefully you are. I hope you are sitting there. And you're saying, oh, man. If only this was like switched around, then it would be 8y minus 7, and then I could cancel. And then I'd look like I'm really smart. You can't cancel these the way they stand. But can I do something to turn this into that? Yes, it's not natural, it's not something that occurs, but you will be faced with scenarios like this. So if it's the first time you're seeing it, pay attention. If I have a difference that doesn't quite match, I can factor out a -1. Because taking -1 and dividing it by both, or taking each one of these and dividing by -1 turns them into their opposite. So if I say instead that this is 8y minus 7 over, if I take a -1 away from this factor, I'm dividing both of these by -1. What's -8 divided by -1? Positive. What's positive 7 divided by -1? -7. Sorry, running out of room here. And now do I have a common factor? Now I do. So I can cancel these, leaving me with just a 1 on the top. Now you can leave this like that. I doubt a MathXL program would accept that as the final answer. So I'll just give you as much as I can. This negative, you can put the negative sign here and just get rid of that 1, or you can distribute that -1 back into both of those, back into both of those terms. But this is like, I'm telling you, it's not going to accept that on MathXL. It's probably better if we take this -1 and we bring it into both of these and we turn this into 1 over -7 minus 8y. I think that's probably a little bit more acceptable. I mean, both of them are right, and I would imagine on a math test, if you're worried about that sort of thing, that's acceptable. I'm sure it is, no matter who your teacher is. But this is a little bit simpler to look at.